Hello and welcome to the first video in a new series. It is all about setting up this thing here. This is a PixHawk flight controller. The specific one is a Holybro PixHawk 6C. I did a video about it a couple of weeks ago now where I was talking about what this is, because I did a PixHawk 2020 series. I'll put a link down below if you want to go and have a look at that. And quite a bit has changed and been updated. And there are new hardware options out now if you want to use a PixHawk flight controller. So it's about time I redid that series. I need to say a big thank you to Holybro for sending me this flight controller to use in this series, because this is a slightly less expensive option than some of the others are kicking around. Now I'm going to install ArduCopter on this, and in addition to this flight controller I'm going to use one of the Holybro M8N compasses, and we're going to install the whole thing onto the Holybro X500 V2 frame. So it's very much a Holybro themed series, this one. But that does mean that then we'll have a large quadcopter that I can use for showing things on ArduPilot, potentially doing things with modern telemetry radios, potentially got a gimbal coming in that we can put on that larger frame and have a play with. So it'll be handy for me to have a modern updated version of this series. So if you are new to this and it's something you've been wanting to do and you want to know a little bit more about how you configure ArduCopter, which is just one of the ArduPilot family. So ArduPilot is a software family with ArduCopter, ArduPlane, ArduSub, ArduBoat, ArduRover. There's quite a lot of them in the family. We're going to use ArduCopter because this is going to go on a quadcopter. So in this video, the plan is what we'll do is we'll flash this with the latest and greatest version of ArduCopter using a program called Mission Planner, and we'll go through the basic setup and also how you configure everything on the radio. By the end of the video, we'll be ready to install it onto that X500 V2 quadcopter frame and do all of that configuration and testing. So all links are down below, as well as time codes. So if you want to rewatch a bit, if you're not sure, it's easier to find. So the first job we need to do with this flight controller before we do anything else and start plugging something in is to flash it with the latest version of ArduCopter. Because we're going to install it into a quadcopter frame, ArduCopter is the version that we want. Now there is the little SD connector on here, the USB connector. So that's the one we're going to plug into. Now, before we do that, jump onto the computer. The thing we need to do this is something called Mission Planner. Now, I'm going to put this link here at the top in the description down below, and you're going to click on download the latest Mission Planner from here. It'll download the MSI file. It's a Windows only application, unfortunately, but it is by far the best way if you're relatively new to setting up PixHawk to go through the entire process. So I've already downloaded it, and then I've run the MSI that was downloaded, and it's installed on my computer. A Mission Planner, when it is running, looks something like this. So we are going to plug the flight controller in, and we should see quite a few LEDs flashing away as it boots up, and then it should appear in Mission Planner. Now the flight controller is shipped with a version of firmware on it at all. This isn't the latest version, it isn't ArduPilot. So you can see here it's appeared as COM10, it'll appear as something else on your computer. But if we click on that, that will then allow us to talk to the flight controller and to set it up and do everything else. However, I wouldn't necessarily recommend doing it that way. I think it's time, while you're making something brand new, to take advantage of all the latest technology that's available. Now, as I kind of insert this, you can see as I move the flight controller, here we go, all the artificial horizon is moving. So it's kind of almost ready to go out the box. However, let's disconnect and let's go into setup and go into install firmware. Now, we are going to try and do it the old-fashioned way. So we're going to install Copter V432 official. We'll click on that. We'll say, yep, that's what we want to use. It'll download it from the internet. And it appears to have found it, and it appears to be having a go at doing the flashing. Now, if you have problems doing it this way, and particularly if you're using a flight controller that is not recognized by Mission Planner, there is this address here that you can download the right file from here. The .apj is the one that you want for the board that you're using, and then you can kind of load a custom firmware onto it. But as you can see here, with the latest versions of Mission Planner, it's done it all itself. We haven't had to select a flight controller or anything. So now it's rebooted. Let's go back into data. Let's make sure it's still appearing as the right COM port. Now we have two new COM ports appeared. These are ArduPilot COM ports. One is for talking to the flight controller itself. That's COM 11. COM 12, and again, these numbers might be different on your computer, is here for us to talk through the CAN bus connection into CAN bus connected peripherals. Now, we're not going to use any of them in this little mini series, but that's what they're for. So we're going to select COM 11 and we're going to click on connect, and hopefully, if it's all working, we should start to get the data across. And here we are, the artificial horizon is moving in the same way, and the flight controller is now flashed. It's super easy with the latest version of Mission Planner, and this is exactly why I recommend you use Mission Planner for stuff like this, because it makes it an awful lot easier, an awful lot harder to make a mistake. So now we have it all flashed, we need to start going through the settings. Now, I would recommend doing this before you plug everything else in, because one of the first things we need to do is accelerometer calibration. Now, I'd recommend when you plug USB cables in, top tip is always plug it into the flight controller first and then plug it into the computer. That way there's no accidental kind of double bouncing or double connection on the flight controller connector, and it kind of saves that wear and tear as well. So here back in Mission Planner, we're going to click on Connect, and once we're in Connect, we'll go into the Setup tab. And in the Setup tab, we want to select Mandatory Hardware. And each of these are the kind of ones that we need to go through. We don't need to go back down all the way down to Hardware ID and ADSB stuff, but up here, we need to go through each of these in turn. Now, frame type is the first type, and that's what we can tell it that it's actually set at. At the moment, we can choose the kind of quadcopter that we're interested in. It's definitely going to be an X-style configuration. Be aware that the difference between the blue and the green parts are all about the direction of the motors, but we'll get onto that in the next video. Next thing then we need to do is the accelerometer calibration. Now, advanced flight software like ArduPilot wants to know what the flight controller feels like in all of the 6 orientations. It might feel a little bit overkill, but it's actually the way that not only ArduPilot, but iNav and others do it as well. So here on the computer, we're going to click at the top one that says Calibrate Excel, short for accelerometer, and it'll give you an idea of what you need to do. It says, please place vehicle level. So with the flight controller level on the desk, we're going to click when done. Then it'll tell us to put it on its left. Now, on a flight controller like this, you have the big arrow. This is actually the front of the flight controller. So if that's the front, that is the left-hand side. So this is why I do it without everything installed, particularly with boxy ones like this, is they already have flat sides to make it easy. So we'll click it on its left, say done. Click it on the right. That's a little bit more tricky because that's where the USB cable is. So I've just put that on the edge of the desk for this one. We'll click done. Next one then is nose down. If that's the nose, then that is nose down. Click on done. Nose up is the other way around. Just make sure it's nice and flat. The key is to not move it when you press the button. And place it on its back. So we need to place it flat upside down and click again. And it says calibration successful. The other thing you can do is level your autopilot to set the default accelerometer offsets. Because this is going into a quadcopter, we can do this here because it's going to be mounted flat on the quad. We can just put it on the desk and say calibrate level, and then we have calibrated the accelerometer. That's that bit done. Now, before we can go through all of these other pieces, what we really need to do is to do things like attach the GPS and compass, and also do things like connect the radio. So to create the new model on your radio, I'm using HTX version 2.8 here, but the process is very similar. Check the documentation for your own manual. We're going to create a new model. So we're going to go into on HTX, select model, and we're going to select new model. Now it'll give us a choice of wizards. We're just going to say blank model, and it's as easy as that on HTX. Now if we press the model button and we tab across, we will see that in the mixes, we have 4 channels set up: aileron, elevator, throttle and rudder. We will need to add a couple of extras. First of all, on channel 5, we will add an arming button. Let's call it arming. Click on the switch that we want to use for arming and hit enter. And then if we just exit out of that, we're also going to add in another channel. Let's put it on channel 6 and we're going to call this mode. And again, we'll click on there. We'll select the channel switch that we want, click enter, come out of that, and now we have the AETR, SG is arming and SE is mode, but you set those 2 up for yourself. Now, the only other thing we need to do, and this is the same for all ArduPilot stuff, is we need to reverse the elevator. So let's just make a note. Elevator is channel 2, so we'll go into the outputs, we'll go onto channel 2, and we'll edit it, and we'll change the direction for the elevator. Now we can change that in ArduPilot, but I've always done it on the radio. It works really well. And then that should work. Now if we just very quickly put some stuff on the screen, so let's just set up the widget and do something like the outputs. We can now see that as I move the controls, everything is moving around. We have channel 6 has 3 positions and channel 5 has as well. If we move the sticks to the top right hand corner, they all go to their maximum value apart from elevator, which is channel 2. That goes to the low value. If it's set like that, we're in good shape. We just need to then bind to the receiver, and I'd recommend for a simple setup using an S-bus receiver. So the next thing after the radio, let's do the compass calibration. Now the compass, there's actually several compasses, but I would recommend we use the compass that's actually inside this. Now this is the cheaper of the 2 GPSs that you can get. This is the less expensive one that has the plug here that's going to plug directly into the GPS 1 port on the flight controller. Just kind of snaps in there like that. There is also another version that goes into the CAN bus. Now this is a slightly more expensive GPS. However, you use this one if you want to put your GPS quite a far distance away. So CAN bus tends to be used on much bigger, more expensive models. However, for this stuff, it's quite a reasonably long cable on this. This is perfect for what we're going to need. Now you'll notice that both of these things have an arrow on the top, and they need to be pointing in the same direction for the calibration purposes. So the way I would do this is I'd just get yourself a piece of, it's called blue tack here in the UK, or a piece of tape. And what we're going to do is we're just going to stick the GPS onto the top of the flight controller, matching the direction of the arrows. And that way, as we move the 2 together to do the calibration, it's all going to work fine. So with that set up like that, let's plug it back into the computer. And then what we'll do is, we did accelerometer calibration last time, we'll go in here into compass. Now here we can see that there are a couple of different compasses listed. Both of them could be used. However, I potentially wouldn't use the internal one. The internal one is going to be closer to other parts of the high current electronics that could interfere with it. Using the external one in the GPS is a good idea. So at the moment, the way it works is that if we just move the external compass to the top, we'll just move that up. There we go. So the external compass is now compass 1. We're just going to disable compass 2 and 3, and that means that the external compass is the only one that we're going to use. Now we're going to start the calibration here. When I click start, what you need to do is hold the flight controller in each orientation and rotate it 360 degrees. So you're going to do it like that, you're going to do it vertically, you're going to do it on its side. And while you do that, this green bar here is going to fill up until it gets to the end and tell you that it's good. So let's click on start. It will say reboot required, reboot now. That's because we've moved everything around. So let's let that do it and replug it in, just so that it restarts with the compasses in the right order for us. We'll click on connect again. There we go, it's come back. Yes, it's remembered everything. So we have an external compass, which is in the puck, the GPS puck that's on it, and we can click on start. Now we need to move it around in each orientation and just keep doing this in each orientation. Do it away from magnetic field, so do it away from, you know, large bits of metal and things like that, and just keep doing it in all orientations like this until eventually the green bar fills up. Let me skip to the end for this. So there we go. It now says, please reboot the autopilot. So we'll say OK. So let's click on disconnect. We'll unplug the power from the computer to reboot the autopilot. And now when it comes back, the GPS will be set. Now, the other thing we need to do is to connect our radio. That's the next part to do the radio calibration. Now, one of the cables that comes in the kit looks like this. So it's a connector, but it only has 3 wires on it. That's the one that we need. And there's a connector here on the PixHawk 6C that says PPM S-Bus receiver. We're just going to plug that one into there like that. And then we have our receiver connected as well. Now we're going to turn on our radio.
Welcome to HTX.
And we'll have that ready by the side, and we'll plug the flight controller back into the computer.
RF signal low.
And now we see the receiver is connected. We have a green light. It's all powered from the USB port. So now we can do the next part. So again, back on the computer, we're going to click connect again. This time we're going to set up the RC inputs. So let me move this out of the way. Let me put the radio in the frame here instead, because that's going to be more useful. So here we are looking at the sticks of the radio. So we're going to click on radio calibration. And hopefully, as we move the sticks, they're going to move on the screen. There we go. So as I raise the throttle, this is a Mode 2 radio. We can see it moving here on the screen. Similarly, if I move the rudder to the left, the value of yaw goes down. Move it to the right, the value of yaw goes up. This is exactly what we want. As I move the roll, again, this is Mode 2 to the left. Roll at the top of the screen there goes down. Move it to the right, it goes up. This looks really good. The trick is with elevator. As I pull elevator down, the pitch value should go up. As I move it to the top position, the pitch value should go down. That is perfect. Now, as I flick the other 2 switches, we should see channel 5 and channel 6 going up and down. That is really promising. So what we need to do is we need to calibrate the radio. So we're going to click on Calibrate, and it says, ensure that your transmitter is on, your receiver is powered and connected. Ensure your motors do not have the power, and we have no props. We haven't plugged all that in, so we're good. We're going to click OK. So it says, click OK and move our RC sticks and switches to their extreme positions. So we'll click OK, and then what we're going to do is we're just going to move the sticks into the corner of each control. We're also going to flick our 2 switches that we've got set up for arming and for modes. And then click when done, and it says ensure that all your sticks are centered. So we'll center all of our sticks, including the switches, and we'll say OK. And now if we click OK, we have the radio calibrated. Now there are a couple of things in here that we're going to need to change in order for channel 5 to be arming and channel 6 to be the mode channel. Now, to set those 2 things up, we need to go into the config tab, and then we need to go into the full parameter tree. Occasionally you have to do this with some of the stuff in ArduCopter and ArduPilot. Don't worry about it, it's very straightforward. Here on the right hand side where it says search, we're going to search for 2 things. The first one is RC5_option, which has appeared here, and we're going to set that number to 153. That tells ArduPilot that that is going to be the arming channel. We're going to hit enter on the keyboard, and then we're going to click on write parameters just to save that. So that's now our channel 5 set up for arming. The other thing we need to search for down here is the thing called FLT mode_CH, and there it is. By default it's set to channel 5. We're going to change that to channel 6, hit enter, and again we're going to write the parameters. If we say OK, that now means that channels 5 and 6 on our radio are the right way round. Going back up to setup then, we have done the vast majority of the pieces. We've done the frame layout, we've done the accelerometer calibration, compass, radio calibration. Servo output we'll look at more in the next video. Servo output, it tells you where all of the connections need to be made. And because we've set it up as a quadcopter, here is motors 1, 2, 3 and 4 set up on outputs 1, 2, 3 and 4. The only other thing we could do is flight modes. We can set up flight modes 1, 4 and 6. Just for setup, I would set up flight mode 6 as return to launch. That's going to fly it back and land it back in case something goes wrong. And I would set the flight mode 1 to be something like stabilize. And I'll just click on save modes. Now at this point, with everything connected to the flight controller, all we have to do is plug in the PWM module into the PWM out here at the bottom, and that's going to allow us to then plug in the ESCs for our quadcopter and do all of the pieces. So there we have it. That is the little PixHawk 6C from Holybro set up with the latest version of ArduCopter. In the next one, we'll put it on top of the X500 V2 frame, and we'll go through all of the wiring and how you set that up, how you do the power, how you do the configuration pieces, how you do things like motor testing. The nice thing with that X500 frame is it kind of comes easy to plug together, so it's relatively straightforward, but the process is the same even if you're using another frame. So join me in the next video in the series where we'll continue setting this up. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that if you're trying to learn a topic will take you from the basics right the way through to some pretty advanced stuff.